Welcome to Section 6 of Learn Go in 3 hours. In this section, we explore concurrency in Go using Goroutines, channels, and select. Concurrency in Go is very different from the way that concurrency has been implemented in previous languages, and we'll learn how to use this style and what its benefits are. For our first video in Section 6, we are looking at CSP and Goroutines. Most programming languages, they provide concurrency by defining threads as a unit of execution. Each thread is mapped to an operating system level thread, and threads share data by attempting to acquire locks on shared pieces of data. Many languages like C++, C, Python, and Ruby, they have their concurrency support in libraries. In the case of Python and Ruby, there's a global interpreter lock that prevents real parallel execution. Java has some built-in support for concurrency with a synchronized keyword, but most of its concurrency support comes from its standard library. Go is different. Its concurrency model, arguably its most famous feature, is based on CSP. CSP stands for Communicating Sequential Processes. It's a style for concurrency that was described in the 1970s in a paper by Tony Hoare, the man who invented the quicksort algorithm. The patterns described by CSP are just as powerful as the standard ones, but are far easier to understand. Go's concurrency is primarily baked into the language with operators and keywords, but there are some types and functions in the standard library to make concurrency a little bit easier to use. The core concept of Go's concurrency model is the Goroutine. Goroutines are lightweight processes managed by the Go runtime. They are not threads. Threads are managed by the operating system, while Goroutines are managed by the Go runtime scheduler. The Go runtime creates a number of threads at startup and then schedules Goroutines across these threads automatically. This has several benefits. First of all, Goroutine creation is faster than thread creation because you aren't creating an operating system level resource. Second, Goroutine stack sizes are smaller than thread stack sizes and can grow as needed. Third, switching between Goroutines is faster than switching between threads. Due to these features, Go programs can spawn hundreds, thousands, even tens of thousands of simultaneous Goroutines. Try doing that with threads in some other language and you will watch your program fall to its knees. And now that we've talked about some theory, let's get into some practice. You can go to Visual Studio Code and create a new project at Go, source, github.com, your username, and then a new folder called Learn Goroutines. Inside of this folder, create a file called learngoroutines.go. And here's the content for the first file. In this program, we have a function called runMe that prints a message to the screen. And on line 10 in our main function, we call runMe with the keyword Go in front of it. That keyword tells Go to launch a new Goroutine and run the runMe function in that Goroutine. And if we run our program, we use go run learngoroutines.go, we get nothing. So what's going on? Nothing was printed because the main Goroutine, the one that's launched automatically when our program runs, it didn't know it had to wait for the new Goroutine to complete. When that main Goroutine reaches the end of the main function, your program exits, even if there are other Goroutines that haven't finished running themselves. So, how do we wait for a Goroutine to finish doing its work? There's one way that will work for our simple case, but should never be done in a real program. You can simply pause for a bit, and here's what that looks like. We have added a single import and a single function call to our program. On line 5, we import the time package from the standard library. And on line 14, we call the sleep function in the time package to tell the main Goroutine to pause for 1 second. If we run our code now, we see our print statement executes, and after a slight pause, the program exits. However, this is a terrible idea because you never know how long a Goroutine might need to do its work. Rather than inserting pauses using sleep, you should wait until a Goroutine finishes its work by using a wait group. And here's what that looks like. On line 5, we trade in our time import for an import of the sync package from the standard library. And there are several useful types in this package, including wait group. On line 13, we declare a variable wg of type sync.waitGroup. We don't have to initialize it, just declare it. We then call the add method on wg, passing it the value 1. And this tells the wait group we've added 1 Goroutine to run. Then on line 15, we launch a closure as a Goroutine, and in the closure, we call runMe. And then on line 17, we call the done method on wg, saying that the Goroutine has completed. On line 20, outside of the closure back in main, we call wg.wait, which pauses the main Goroutine until the count of running Goroutines tracked by the wait group reaches 0. When it does, the main Goroutine continues running, and since there aren't any more statements in main, the program exits. If we run this code, we'll see that our message gets printed immediately, and then the program exits immediately afterwards. There's an important pattern here to notice. RunMe doesn't know anything at all about Goroutines, wait groups, or anything to do with concurrency at all. The only thing it does is its business logic, and this is an important pattern. Most of the code that you run in Goroutine should have no reference to anything dealing with concurrency. Try to keep your concurrency logic separated from your business logic. Now, this is a boring program. We could have already printed out a message without using Goroutines. In order for a Goroutine to do interesting work, it needs to have data to work on. So let's finish up this video with a look at how to set up a Goroutine with data. Since a Goroutine is launched by preceding a function call with the keyword go, you can probably guess how to pass data into a Goroutine by passing values into the function that you are launching. So let's change our program slightly so we are passing in a name. We've changed RunMe slightly, so now it takes in a parameter and prints it out. We've also changed our closure slightly as well. So now it takes in a parameter called name of type string, and on line 18, we pass the string Bob into our closure. When we run this code, we get the output that you would expect. And while you can refer to variables declared in the outer function directly, like we do with WG inside of our closure, you need to be careful when you do so. If you access a variable directly and the variable's value is changed before the Goroutine runs, you won't get the value that you expect. So here, for example, is an attempt to launch 10 Goroutines in a for loop, passing a different value to each Goroutine. In this program, we're going to loop from 0 through 9 inclusive, and for each value, we increment the count of running Goroutines on line 11, and we launch a Goroutine that prints out the value of I and then calls wait group done. And then when the loop is over, we wait for the Goroutines to complete. If you run this program, you don't quite get the output that you'd expect. You're going to get something with a bunch of 10s and maybe 1 or 2 print statements with a different number. And that's because all of the Goroutines are sharing the same variable I, and most of the Goroutines won't run until after the for loop exits and I's value is 10. If you want to actually pass different values to each Goroutine, you should pass I in as a parameter to the Goroutine function, and that looks like this. So we made a little change to our code. We added an input parameter to our Goroutine closure, and then we pass in the value of I every single time another Goroutine is being launched. And then if we run this program now, we'll get back the values from 0 through 9 in a random order each time we launch it. So in this video, we've learned about CSP, how to launch a Goroutine, how to wait for one or more Goroutines to complete, and how to initialize a Goroutine.